This outer coat, anybody know what it is?
The fascial
Sac.
Not a facial sac.
Not a facial sac. That's a Stop and Shop bag
over
your head. So facial sac, it's really strong. And so you might wonder, why is it so strong? This is made out of the aponeuroses from the abdominal muscles. So when the inguinal ligament forms, it forms from the aponeuroses of the external, internal, and abdominal obliques and transverse abdominis. And it goes from the pubic tubercle to the ASIS. It goes straight across there. Okay, and so let's for a moment imagine that my glove is the inguinal ligament. And the testicle comes down, and when it does, it pushes through the inguinal ligament, and it takes those aponeuroses with it. Follow? Mm-hmm. Okay, so that's what these are. Now, there's a difference between the fascial sac and the spermatic fascia. This is the spermatic fascia up here. And the spermatic fascia goes around the spermatic cord. The spermatic fascia has the cremaster muscle. Cremaster muscle is a thermoregulatory muscle, and it comes from the internal abdominal oblique. But there isn't any peritoneum in the spermatic fascia. In the fascial sac, the deepest side has peritoneum covering it, but it doesn't have any muscle. So the fascial sac, no muscle, but it does have peritoneum. Spermatic fascia has muscle, but no peritoneum. Originally it had peritoneum, but it broke down. It goes away. Okay, then I want to show you something, because we're going to see this structure is found in the female also. If you take the fascial sac and lift it up, you'll see that the testicle comes with it. And that's because they're attached right here where my finger is. And that point of attachment is called the gubernaculum testis, or scrotal ligament. And that is the remains of the gubernaculum. In the female cat, we're going to see the round ligament of the uterus, and that's the remains of the gubernaculum also. So females and males have the same structure, just end up in different places. Okay. If we take the testicle, we cut through it here, you'll see that there's an outer covering. And this is the tunica albuginea. So tunica albuginea is kind of a generic name for a coat around organs. Like, this is not the only organ that has a tunica albuginea, but that's what that is. And then if you open this up, you see that this is the inside of the testicle here. We have seminiferous tubules in here. So the seminiferous tubules are where meiosis occurs and the spermatozoa are produced. But when they're produced, they don't have a flagellum. They just have, they're a cell with half the normal number of chromosomes. From the seminiferous tubules, they get pumped into the rete testes, R-E-T-E. Actually, if you have your Great Sperm Adventure, you can probably follow along, because that's on there, right? So the rete testes, then they get pumped from there to the seminiferous tubule. Seminiferous tubules. No, vas efferents. So vas efferents go right up the middle of the testicle, right here and right here. And you probably can't see it. I'll try to focus it. Oh, I can't see it now because the thing turned off. But see if I can get that focused. Okay, right here, there are a whole bunch of little tubes. So in a male human, there are about, I think, 16 or so, plus or minus 16 vas efferents in each testicle. And the vas efferents pump the spermatozoa up to the head of the epididymis. So that's the next place they go, right here. And the epididymis kind of looks like a tadpole on the posterior side of the testicle. So this is the head of the epididymis, this is the body of the epididymis, this is the tail of the epididymis. And inside, all the vas efferentia converge into a single duct. It's called the duct of the epididymis. And if you look down here, I think even with this, you can see there are all these little holes down here. What happens is this duct of the epididymis winds back and forth in the epididymis. And in a human, the duct of the epididymis, I think, is supposed to be something like 80 feet long. So the testicle is maybe 3 inches, 2.5 inches, 3 inches or so. So you have the epididymis, which is about 3 inches, with a duct inside of it that's about 80 feet. You don't have to be a brain surgeon to figure out that that duct is really small diameter, and then it doesn't just go straight from one end to the other, it just winds back and forth and back and forth. So when they cut through here, or when I cut through here, you can see all of these openings because they're down here in the tail of the epididymis where they've been cut through. Now the spermatozoa spend about 20 days or so in the duct of the epididymis. And during that developmental time, they develop a flagellum. And then, after that has occurred, if there's ejaculation, the spermatozoa get pumped from the duct of the epididymis into the vas deferens. So vas deferens is over here. It's going through this right here. And if you feel this, you can feel there's a tube inside. That's the vas deferens. And the vas deferens pumps them up. It goes up through the spermatic cord. It enters the body cavity after passing through the inguinal canal. It goes over the ureter, down the posterior side of the urinary bladder, and it meets the seminal ducts that come from the seminal gland. So when those two come together, it looks like a Y, right? You have vas deferens, seminal ducts, they come together and they form a new duct called the ejaculatory duct. And we won't be able to see any of these things on the cat. In fact, we won't see these things in the bull testicle either. So the spermatozoa then get deposited, the ejaculatory duct pierces through the prostate gland, sort of like a straw going through an orange, and then dumps the contents into the urethra. The prostate gland secretes separate fluids, prostate fluids, which are pretty much the same as seminal fluids. And I think I might have mentioned there are actually 30 to 40 prostate glands, it's not one. And the prostate gland develops from the wall of the urethra. So the urethra always passes through it. And then the semen get pumped down through the urethra and out of the glands and into the vagina. So the bulbourethral glands, which we'll see on the male cat, secrete a mucal secretion into the urethra, and that lubricates the urethra, makes it easier for the semen to be pumped, and it also neutralizes any urine that might be residual in the urethra, because the urine tends to be acidic, and that would kill the spermatozoa. So a couple of things that are kind of important there. One is, you notice I said that the spermatozoa need to spend about almost 3 weeks, 20 days, in the duct of the epididymis to develop a flagellum so they can swim. So if a person or any mammal ejaculates too often enough, what will happen is all the spermatozoa with the flagella will be pumped out, and the remaining cells will be immature, and they won't have a flagellum and they won't be able to swim. That's called sperm exhaustion. And so the obvious question is, well, how much is too much? So when I managed a breeding farm with horses, we figured you could use a stallion twice a day was really not a problem. 3 times a day you'd get away with for a while, but eventually you start to get into the problem of not having a viable spermatozoa being ejaculated. And when you're breeding mares for somebody and they're paying you for it, they kind of expect the mares to get pregnant. So if your stallion isn't producing any viable spermatozoa, they don't get pregnant. That makes everybody unhappy. So 2 times a day is about max. this is not a good birth control method. So if you are talking to some guy and he says, "Oh baby, don't worry about me, I ejaculate 8 times a day," you should say, "Good for you," but you don't want to count on that as being a reliable way of preventing impregnation. Now, there's another issue with respect to viable spermatozoa, and that is the temperature of the seminiferous tubules when the spermatozoa are developing. So they have to be 3 to 4 degrees Celsius cooler than body temperature. So that comes out pretty close to 7 or 8 degrees Fahrenheit. If the testicle is too warm, then the